Haskell is what we call a lazy language. This is in comparison to some languages which are strict or eager in terms of their evaluation. But what lazy essentially means is the evaluation technique that Haskell takes is that it does not evaluate something until it absolutely has to. So for example, if you pass it two arguments, it will only evaluate the arguments, the function will only evaluate the arguments that it needs to in order to return a value. If it doesn't need to evaluate an argument, it won't bother to. This is in contrast to something like Java, where all of your arguments are evaluated as they are passed to the method, and then the method can execute. In Haskell, it will try to do as little work as possible. Now, this can save time in terms of efficiency, but it can be a little bit tricky to reason about. So we're going to dip our toes into the world of laziness today. We'll probably see more in-depth concepts with laziness as we go along, maybe to do with control structures or such. But today I just want to give you an idea about what this can mean in Haskell. So I've got a couple of basic functions here. This one's a little bit more complex, but we'll get onto this. So first here takes an x and a y and returns x. So this function shouldn't really need to worry about what y does, because all it does is get rid of y. And indeed, in Haskell, what we can do is we can say first, let's say I want to give it two numbers, so let's give it a 5, and then let's give it something that's going to be very difficult to evaluate. So let's give it the length of the infinite list starting at 1. So, of course, the infinite list is something that the computer itself can't actually evaluate. It can't really deal with the amount of room that would take to store, because it would take an infinite amount of room to store. So we should get a Stack Overflow. But because we're lazy, Haskell doesn't bother to evaluate the second argument. Haskell just looks at the first argument, sees that's all it needs, and it will return that value for you. Now, of course, if we swap these around, Haskell will struggle, because Haskell has to now evaluate the infinite list, and it will go on and on and on. So let's just kill that before we get a Stack Overflow. So in that instance, if we understand the order of the evaluation, we can use that to exploit some things that we wouldn't otherwise be able to. Similarly here, in this definition of list2n, now in this function I'm taking a value n, and I'm saying take the first n values from a list. That's what the take function does, takes the first n values from a list. But you'll notice here, my definition has an infinite list built into it. Now, of course, if I was in an eager evaluation language, it would have to evaluate this list and before it could return a value, unless you were using some special libraries, and for Java, for example. So, if I come down here and I list2n, and let's just say I want 5, I can get the first 5 elements of this list, because Haskell doesn't bother to evaluate the whole thing. It sees take 5 and it says, okay, well I only need to produce 5 values, so we'll look at the first 5 values of this list, and then we'll stop. It doesn't bother to evaluate the rest of the list. Of course, I can change its value if I want more values and get as many as I want. So this is one of the benefits of eager evaluation, or lazy evaluation, is that it can allow you to exploit the way that your code operates. If you understand how it operates and how it executes, you can avoid dealing with things like infinite lists, or you can deal with infinite lists, but you can exploit them to your advantage. Now, similarly down here, I have something a little bit more complicated. So I have an AND statement, which has got a statement on one side. This is a very simple statement on this side, and I've got something much more complicated over here. Now, the only thing you really need to understand is this is something that has to work over an infinite list. We'll look at fold statements later on, our functions, but this is just something that looks over an infinite list. That's what repeat true does. So this one has to evaluate the infinite list of just true, comma, true, comma, true, comma, true, over and over again. This one is just x is less than or equal to y. Now, in an eager evaluation language, we might have to evaluate both sides before we could determine what the overall statement is. But here in Haskell, the AND statements and some of the Boolean operators will use what's called short circuit evaluation, or I think it's McCarthy evaluation as well, which is that if the first argument is sufficient to understand the output from the whole argument, it will just evaluate the first argument and not bother about the second. So let's have a look and see what that means. So let's say I want to give it something that's false here, because I know that if the first argument in an AND statement is false, then the whole thing is false. It doesn't matter what the other side is. If it's false, then I'm fine. So let's say we want to say 50 is less than 5. So that should return false on the left-hand side of the equals here. And that should mean we don't have to deal with this infinite statement. So if I hit enter, I get false out, because Haskell is short-circuited. It's used its lazy evaluation to say I have enough information to calculate the whole thing. let's just leave it there. Whereas, if I say 55, this should return true here. Now, if I return true here, this means that Haskell does actually have to evaluate this side of the argument. And when it tries to evaluate this side of the argument, it's going to fail. So we'll just get something that goes on and on and on. Because as I say, this thing has to traverse an infinite list, checking each value as it goes along. And clearly it can't do that. So we get something that just hangs as fold R tries to traverse the infinite list. So this is just a brief introduction to lazy evaluation, but it's something you should understand is one thing that makes Haskell quite different from languages like Java, and I think Python's also eager as well. But just essentially what you should take away from this is that Haskell will only evaluate what it has to evaluate. It will not evaluate anything more than that unless you force it to, or unless it has to. So this is something that will inform your programming decisions going forward. Sometimes you can use this to make your life a lot easier and your code more efficient. But this is just a general idea. As I say, we'll likely see more advanced concepts to do with lazy evaluation as we go forward. But that's everything for today. If you have any questions about anything I've covered, please do let me know. Thanks.